Alrighty, name at the top. Let's begin. We're talking about measurement, mass, and volume. Some of my favorite math concepts. Now, if we're talking about weighing things in kilograms, and we're talking about what object weighs 1 kilogram, what are your thoughts? I'm going to give you just some equivalents to help you out. Because we're used to pounds, and 1 kilogram is about 2 pounds. So if you had to say to yourself, well, which one of these objects is about 2 pounds? Would you say that's maybe this big book, a cupcake, a paperclip, or an elephant? Well, 2 pounds isn't too much, so we're not going to say it's an elephant, but paperclips are pretty light, and so are cupcakes, so my gut would say to go for that book. Now, if we're talking about grams, oh my goodness. Grams, tiny, tiny, tiny. They weigh very little. So if I had to say maybe about grams to pounds, I'm going to do my little Google here. Let's see if I did the equivalent here. So 453 grams are in 1 pound. Oh my goodness. So that's pretty impressive. And then in 1 kilogram, let me see, I can write this down just so you can see it. 1 kilogram, there's going to be 1,000 grams. So grams, are very, very, very tiny. So which one of those things would be 1 gram? If it's super, 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 super light, I'm probably going to be aiming for that push pin because those weigh very little. Talking about 1 liter of liquid over on number 3. And if you think about it, like a large soda bottle, a large one, is about, could hold 1 liter, and those big, big soda bottles would hold 2 liters. So if we're saying which one of these would hold about 1 liter, well, probably that soda bottle would be my guess. That's what I would choose. Because your your cup of coffee or hot cocoa, whatever's in here, is smaller, usually smaller than a bottle. A bucket holds quite a bit. You'd have to pour a whole bunch of these into here. And then if we're talking about a pool, oh my goodness, you'd be pouring thousands of these into the pool, okay? A fish tank holds 200 liters of water. If 88 more liters of water are needed to fill the tank, how many more liters of water are already in the tank? So it has to get to 200, but you need 88 more. So I would probably do like a 200 minus 88 to figure out the answer. And I'm going to let you solve that one on your own, okay? Pause that video, press play when you're ready to go to 5. Michael feeds his dogs about 5 kilograms of dog food per day. About how much dog food does he feed his dog in 10 days? So that'd be 5 in 1 day. But you have 10 days. So you're going to do 5 10 times. And I'm going to let you solve that one on your own too. Pause and press play when you're ready for number 6. The mass of 12 grapes is 72 grams. Each grape has the same mass. What is the mass of 1 grape? Oh, finally, we're back to division. It's been so long. So we're going to basically take that 72, divide it by 12 to get our answer. If we flip-flopped it, remember, we could always put that largest number on the other side of the equal sign. We'd have a 72. And then we could say, what number times 12 equals 72? And I'm going to let you solve that one on your own. Number 7, Mrs. Brown uses 8 bags of flour a day to bake cakes for her bakery. Each bag has a mass of 6 kilograms. How many kilograms of flour does Mrs. Brown use each day? Well, she uses 8 bags each day. Each bag has 6 kilograms. I'm going to highly suggest you multiply those numbers to get your answer. And you can pause and solve and press play when you're ready for number 8. Rosa had a fish tank filled with 56 liters of water. She emptied the fish tank by filling a container that holds 7 liters of water. How many times did she fill the container to empty the fish tank? So she's dipping this bucket into the fish tank to get the water out. But the bucket only holds 7 liters of water. So each time she dips the bucket in, she takes 7 liters of water out of this fish tank. Okay, so this is, fortunately, it's been a while, but I'm so happy that we finally get to do some more division problems. So to set you up, you're going to take 56 divided by 7 to get your answer. Don't forget, you can take that largest number, put it on the other side of the equal sign, and you can turn that into a multiplication problem if that's easier for you. Solve that one and then press play when you're ready for number 9. Wesley had 2 pieces of bread. They each weigh 25 grams. How much do the 2 pieces of bread weigh altogether? They each weigh 25 grams. There's 2 of them. I'm going to let you solve that. And when you're ready, you can join me on the next page. I absolutely love finding area, so let's go ahead and get this page started by writing our name at the top. And then let's dig in. On number 1, it says, one way to find the area of this rectangle, talking about this one down here, is to count each square. Which of the following is another way to find the area? So I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and count them all. Or I could do something else. What would that be? I could do 6 plus 4, 6 times 4, 7 plus 4, 7 times 4. So this is what I would do. I would count the ones that go across, 1, 2, 3, 4, 5, 6 squares across. Count the number of squares that go down, 1, 2, 3, 4, okay? In other words, if I use my highlighter, I have 4 rows, right? 1, 2, 3, 4. And if I count the columns, I have 1, 2, 3, 4, 5, 6 columns. And to find the area, the number of squares that cover this rectangle, I would take the number of columns times the number of rows, and that would be 6 and 4. There's only one of those here. That's my answer, 6 times 4. Okay, let's go on to number 2. The dimensions of this rectangle are shown in feet. So this is 5 feet tall, 8 feet wide. It says, what is the area of the rectangle? Well, we just said in problem number 1 that we can multiply length times width. So we have length and width. So I need to multiply 5 times 8 to get my answer here. And whenever you get area, our units are not going to be feet, they're going to be square feet. Because up here, if you're looking at my area, I'm trying to figure out how many squares cover an object or a shape. So if I'm trying to figure out how many squares cover this rectangle, then I can say that the answer is going to be in square feet. So area is always in square feet. Multiply 5 times 8, write your answer, and then you can move on to number 3 with me. The area of a rectangular garden Tyler built is 72 feet, which could be the length and width of the garden. So I love to draw, so I'm going to draw this out. Anytime we're talking about area, perimeter, for sure, I'm going to draw it out. So here's my garden. I have my length, I have my width, and we know to get the area, we're going to take length times width. So we know that the area is 72, so we're trying to figure out what number times what number equals 72. So I'm going to let you figure this one out, multiply these, and figure out which one of these is 72 square feet. Okay? Pause this video. After you answer your question, meet me at number 4. Okay, Miss Ashley used square inch tiles to show a model of a window. Which equation set shows 2 ways to find the area of the window? Do me a favor, circle or highlight or underline 2 ways, because there's 2 ways, okay, to find the area of the window. So we know we could count 1, 2, 3, 4, 5, 6 wide. 1, 2, 3 long. So our length and width is 6 and 3. So the ways that we could do it are add them all together. 1, 2, 3. Oops, I need to 1, 2, 3, 4, 5, 6. You could count them all. Or I could take the length times the width. And I'm going to let you find which one of these shows both adding and multiplying the correct numbers. Oops, I went to the wrong one. Number 5. Jessica is using square pieces of paper to cover a rectangular bulletin board. The board is 20 feet long by 5 feet. Ooh, I like to draw. Let's just draw that right now. 20 feet by 5 feet. Okay. Each piece of paper is 1 foot long and 1 foot wide, so that's a square piece of paper. None of the pieces of paper will overlap. How many pieces of paper will Jessica need to cover the bulletin board? So we could draw and solve that, okay? So if each square is 1 by 1, then we know that we're going to have 5 pieces of paper down and 20 pieces of paper across, and we're going to multiply those two numbers to get our answer. And I will let you pause and solve this question. Sam covered the front and back of his math book with contact paper. The front of the book is the same size as the back. What is the total area of the front and back of Sam's math book? So we have a front and a back. They're trying to trick us, but that's not going to work. 6 inches long, 10 inches wide. We know that we need to multiply those numbers to get the square inches, okay? So we know that 10 times 6 is 60 square inches, but there's 2 of them. So I'm going to need you to double that number to find your answer. Pause this video, find that answer, circle it, and then meet me at number 7. Which number sentence shows how to find the area of the square? I could do 1 plus 1 plus 1 plus 1 plus 1, but that's there aren't any options down here for that, so that's probably not a good idea. I could also notice that there's 5 in a row, so I could say something like 5 plus 5 plus 5 plus 5 plus 5. That's an option if it's on there. But we also know that area really is length times width. So how long is it? 1, 2, 3, 4, 5 long. How wide is it? 1, 2, 3, 4, 5 wide. So we would multiply those two numbers to get the area. I'll let you find that answer, and then you can meet me at number 8. A diagram of a theater is shown below. The total area of the theater floor is 23 times 9 plus 7 times 9. So we have the place where people sit and the stage where people perform. So it says, which expression is equivalent to the total area of the theater floor? So are we going to do 9 times 23 plus 7? 9 times 23 times 7? 9 plus 23 plus 7? 9 times 23 times 7? Well, we said that area is length times width. Our length is 9. So we know that this is going to be a 9 times something. So we can't use C and we can't use D, right? Because that says 9 plus and that says 9 plus, and we need a 9 times. And then where's the width? I'll do this in blue. Here's the width. That's the whole width right there. That's 23 for this section here and 7 for this bit here. So what is the whole width? Well, that would be 23 plus 7. So I'm going to let you decide whether you're going to do answer A or answer B now that you know that. And when you're ready, you can meet me on the next page. Going to be finding the perimeter here. Make sure you write your name at the top of the paper. It's a very good habit to get in. Perimeter, love perimeter, because that's the distance around a shape. Katie wants to put fencing around the outside edge of her garden. So if this is her garden, she wants to put a fence around this. So maybe this is where she walks around the garden, but this is where she actually plants her fruits and her vegetables. So she needs to know the perimeter to figure out how much fence she needs to get. So how do we do that? Well, you count the distance around to get your answer. So you could think of it like this. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Well, that ended up being 18 units to get around that garden. And they were very kind and told us that the distance here from one segment of each square is 1 foot. So if we counted to 18, we need 18 feet of fence to surround her garden. Number 2 says the picture below represents a patio. That's like a floor outside that you sit on. Usually it has deck boards on it, or it might be concrete. But it says it measures 6 feet on each side of its 6 sides. So that means each is 6. Each side of it is 6. And it wants to know the perimeter of the patio. We're not doing area anymore, so we need to make sure we're adding every side until we get back to the beginning. Add all of those and circle your answer. When you're ready, meet me at number 3. Ben compared the area and perimeter of the 2 figures below. Which statement is true? So we know that area is when we multiply the length times the width, and we know that perimeter is when we add all the sides. So they're different, because with area, we're trying to cover all of the squares. So if I use the highlighter, that would be like covering each bit of it in whatever you want. So my area there would be adding up all the squares, 1, 2, 3, 4, 5, 6. Or if I did it on the other one, I'm trying to add all of the squares, which I'm not going to take time to do, just to save time. But let's figure this out. This is 1 square tall, but it's 1, 2, 3, 4, 5, 6 wide. This one is 1, 2, 3, 4 long, and 1, 2, 3 wide. So there's a few things that we can do with this. Let's figure out our area of figure A, which would be 1 times 6. So our area would be 6 square units. But this one over here, figure B, would be the area would be 4 times 3, so it would be 12 square units. But if we're going to do perimeter, I'm going to add up all these sides. Watch what I do here in blue. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the perimeter of figure A is 14. Figure B would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the perimeter for this one would be 14. So these numbers are different. Area of 6, perimeter of 14 for this one here. But for figure B, I have an area of 12 and a perimeter of 14. So what's true about this? The figures have the same area but different perimeters? No, all of the numbers are different. Well, actually, perimeters are the same. So that can't be that one. Yep. The figures have the same perimeter but different areas. That's true so far. The figures have the same perimeter and the same... Nope. The figures have different areas and different perimeters. Nope, also not true. So we saw this. I'll use my highlighter that I had a perimeter of 14 for this one, perimeter of 14 for this one, but the areas were different. Number 4, Mrs. Absher bought a rectangle rug for her living room. Which statement about the rug is true? So it looks like we have perimeter and area. So we probably need to figure out our perimeter and our area. Area is length times width. Length length times width. So what is 9 times 12? Well, if you want to, you could break that 12 down into 10 and 2. 9 times 10 is 90. 9 times 2 is 18. Add them together and you get 108. So our area is 108 square feet. But then what is perimeter going to be? Adding all the sides. 12 plus 9 plus 12 plus 9. Because that has to be a 12 and that has to be a 9. What is 12 plus 12 plus 9 plus 9? 22, carry the 2. And then 2 plus 1 is 42 feet would be our perimeter, P. A for area. So it says we need to figure out what is true. The perimeter is 108 feet. The area is 42 feet. The area and perimeter are the same. The perimeter is 42 feet and the area is 108 feet. I'm going to let you answer that question. When you're ready, you can do number 5 with me. Amy wants to sew a fringe border around her square-shaped blanket. Oh, square-shaped, so I'm going to try to draw a square as best I can. One side of her blanket measures 96 inches. How many inches of fringe border does she need? So this fringe border, let's say this is our fringe. The fringe border goes around the blanket. Maybe you've had a blanket that has kind of some fuzzy or furry edges, but most blankets have some sort of a border so that they don't unravel. But she needs 96 inches and 96 inches and 96 inches and 96 inches of fringe. So we're looking for perimeter. I want you to write your answer right there after you have added up all the sides. Number 6 says the square has the same perimeter as the triangle. What is the length of each side of the square? Oh gosh, this is going to be tricky. Perimeter, that means we're adding up all the sides, so we're going to add 8 plus 10 plus 6. So if I stack and add, okay, 8 plus 6 plus 0 is 14, carry the 1. 1 plus 1 is 2, so the perimeter is 24 centimeters. The perimeter of this square is also 24. So if I add up all 4 sides, they're going to be 24. And we know when we're talking about squares, all of the sides have to be the same. So what number, if you add it 4 times, makes 24? For example, if I said maybe it was 5. Well, 5 plus 5 plus 5 plus 5, because there's 4 sides to a square, would be 20, so that's not quite the right number. So I'm going to let you figure out which of these numbers, if you add it 4 times, makes 24. Pause this video, and when you're ready, join me for number 7. Maddie is making a blanket for her mother that measures 54 inches by 68 inches. What is the perimeter of the blanket? Well, I'm always going to draw it. So if I draw my blanket right here, 54 inches by 68 inches. Perimeter is the distance around, so that means I have to add up all of the sides to get perimeter. I'm missing 2 numbers. This number here we know needs to be 54. This number down here we know needs to be 68. Add up all your sides and write your answer right there. Don't forget the units, please. And when you're ready, you can join me on the next page. Shapes with equal parts. You know that I'm a big fan of shapes. They help us do so many things in math. Like this one here, the football coach divided the field into equal sections, as shown below. What area of the field is in each section? So that means when I'm looking at one section, how much of the field is that? Well, the top number needs to be a 1 because I only have one piece that we're looking at. But how many sections did the coach divide it into? Well, if I look, 1, 2, 3, 4, 5, 6, 7, 8. So the bottom number needs to be an 8. So 1/8 is how the coach divided the field. I'm going to let you do number 2. It says, which drawing shows 1/4 shaded? So our top number is a 1, which means I should have 1 piece shaded, but then I need to have a total of 4 pieces. Okay, I'm going to let you figure that one out. When you're ready, press play, and you can do number 3 with me. Kelly wants to draw lines in a shape so each section is 1/4 the area of the shape. Which shape is 1/4 the area of a triangle? Well, this question is worded pretty poorly. So what it should say is, which shape is a triangle if you cut it into fourths? So if I were to cut this into 4 pieces, those don't quite make triangles. Or if I cut this into 4 pieces, not quite. This doesn't quite do it, although I guess I could maybe try the corners. But unfortunately, that doesn't make it even, so that's probably not a good way to do that one either. So then I'm left with D, and I could cut them down the middles of each side. That makes squares, but there is another way to do squares. And if I use some nice straight lines like this here, that one, trying to get that to stick. That doesn't want to stay, but I'll draw one more and then I'll have to get rid of that. Okay, and then I draw another perfect line maybe here. Now, if you take a look at that, that does make 4 perfect triangles, and one of them, if I filled it in, I'm not going to take a lot of time to do that, would be 1/4 the area. Okay, so I would select D for that answer if I was you, and just keeping in mind that when we're talking about squares, we could cut it 2 different ways. Groovy? All right, let's move on to 4. Oh, and some of my shapes are being weird, aren't they? Let's see, do my magic. I'm going to do my touchy thing here just to get rid of these. There we go. The area of Ned's baseball card page is 16 square inches. If Ned divided his page into fourths, what is the area of one section? As usual, I find it helpful to draw it. So I'm going to draw his baseball card page. And it says if he divides his page into fourths, what is the area of one section? So the area is 16. So if the length times the width is 16. And if he were to divide it into fourths, what number 4 times makes 16? Or you could think of what is 16 divided by 4? Or if you flip that problem around, 4 times what number equals 16? Okay, and I'm going to let you choose which answer works for you. Pause that video when you're ready, and then when you're done, you can meet me on question number 5. Jake ordered a pizza cut into 8 equal sections. He ate 1 slice. What fraction of the pizza did Jake eat? Well, he ate 1 of how many pieces? I'm going to let you answer that question. And when you're ready, you can meet me at question number 6. Tara has a fruit cup stand, a fruit stand, that is divided into equal sections. What fraction of the fruit stand is used for each kind of fruit? So we've got bananas, grapes, oranges, lemons, plums, apples. None of these repeat. They're all different. So they want to know what fraction of the fruit stand is used for each kind of fruit. So that means if I was looking at just one section like bananas, that's 1 out of how many? So our top number of the fraction would be 1, and then I'm going to let you find the answer by counting the total number of sections of the fruit stand. When you're ready, you can meet me at question number 7. 3 students sat on equal sections of a park bench. Which bench has the area of 1 student shaded? 3 students sat on equal sections of a park bench. So we need to divide a bench into 3 sections. Okay, it looks like D divided it into 4 sections, so D is not an option. But A, C, and B are fine. Which bench has the area of 1 student shaded? And I'm going to let you take a look at that one, answer it, and then meet me at question number 8. The figure below represents 1/2 of a piece of poster board. What did the whole piece look like? So this is 1/2 of a poster board. What did the whole poster board look like? Well, if you were to flip that shape, let's see if this works. I don't know how well this will work, but I'm going to do my best. If I were to take that shape and separate it, okay? So 1/2 means there's 2 pieces, right? So the other half of the poster board, excuse me, my fingers are not working really well. This is going to be harder than I thought. Boop, boop, boop. Boop, boop, boop. Okay, there. There we go. If I were to flip that around and put that on there, that's about as good as I can do with my fingers. Then you're going to have to tell me what the whole poster looked like. Okay, and I'll let you select A, B, C, or D. Meet me at the next question when you're ready. Mr. Hamby mowed 1/6 of his yard. He shaded a figure to represent the mowed section. So which one of those diagrams matched shows that he mowed 1/6 of his yard? You're going to have to find one that's divided into 6 pieces and has 1 shaded. Okay, and I'm going to let you do that one on your own. Pause the video. Meet me at question number 10 when you are ready. Carrie split her sock drawer up like the diagram below. What area of Carrie's sock drawer has blue socks? So the whole drawer would be considered 1 drawer. So that would be 1. That represents the number 1. So how much of her sock drawer has blue socks in it? Well, there's only 1 section out of how many? So it has to be either C or B, and I'm going to let you choose which one you think it is. And then you're done with your math packet.